Hi everyone, my name is Abel Gray Cantoma. I'm from GREYTEST CAD Design Concept. This is actually my WhatsApp contact. You can reach me on this number or you can call me, okay? These are the list of softwares which I've covered on our YouTube channel. They are very much available on that channel. Go down below the description of this video. You'll find a link to that channel. Go there and actually keep yourself busy. We have covered architectural working drawings, mechanical and electrical service drawings, structural designs and detailing, water designs and road designs, okay, using these softwares. We now teach all of these softwares on our Telegram platform, where we'll give you the software, guide you on how to install it and crack it on your system, okay, just for a token. Why not DM me, okay? Today I'm going to be showing you how to actually design a flat slab using Protastructure. Okay, so I'll be taking you through that process. You can follow me on any of the social media platforms. Down below the description of this video, I actually listed my username on those social media platforms. You can follow me on them. Okay, now this is actually our Protastructure software. I'm going to click on new project and then I will make this flat slab. I'll use underscore to space that, okay, because the space bar here does not actually work in Protastructure, so you have to use underscore. I click on OK. Now I'm going to use any of this template. I'm going to be using BS8110. These are actually code of practice, so you can choose any of the templates here and you can actually even create your own templates. But I'm going to be using BS8110 and I will import this. Okay, good. This is Protastructure environment. I'm going to click on orthogonal axis generator and I click anywhere in this window. I'm actually going to leave this as it is and I will click on OK. Now these are my axes, okay, that has been created. Now I'll come to story. I'll click on story and I right click and I'll insert number of stories. I'm going to make this 6 and I'll click on OK. I'll come back to story 1, okay. I'll go to stories and I right click and I click on edit story. It's actually loading. Okay, good. Now first story bottom level, this is actually from your natural ground to your DPC, so which I'm going to make 450. Okay, the foundation depth, I'm going to make this 1500. Okay, footing, I'm going to leave this as it is. Footing description, I'm going to make this a pile foundation. Okay, so the description here, you can actually insert whatever, let's say shops, okay, so you can write shops for them all, and then this is actually our roof. Okay, so I can actually make this, define this as all similar. Okay, click on OK. I'm going to insert my column point. I'll come to columns, my section manager, click on that and I click on circular column and I click on OK. Now I'm going to use 450 and I'll come eccentricity 225, okay, to centralize that. Then here you can see I'm going to click on insert column drop panel, okay, because this is actually a flat slab that I want to design, and a flat slab is actually a beamless slab, so we have to design a column with a drop panel in order for it to take care of the punching, okay, the punching shear. Okay, so in order to do that, this drop panel, I'm going to make the size 700, for example. Okay, I'm going to make this 350. I'll make this 350. That is 700 divided by 2. So my drop is actually going to be 400, because the thickness of the slab is going to be 200. My drop is going to be 200. So when you sum that, total depth is actually going to be 400. So I'll make this 400. And then I'll do it. And then a column, pick the middle. Okay. So I'm actually going to have a core wall, that's a shear wall around here for my lift. So I'm going to leave this place for that. I take this, take this, take this, take this, take this. Good. You can see the circular column. You can see the diameter of the circular column is actually 450. So I'm going to draw my core wall, and then I'll make this 230, make this 115, I'll make this 115. So I'm not going to insert a drop for this. Okay, so I'll come here, pick the center. Okay, because if let's come back to my wall. You come here, you can see we have the one that you have the grid at the top of it. You have a grid here at the bottom of this, so I can actually decide to shift this so as the grid not to actually be at the center, but I actually want it as it is like this. So here is where you actually make that choice. Okay, good. Now I'll select this wall, I'll right click, I'll come to wall opening editor, I will add, and then the wall width, I just want to create an opening for that. So I'm going to make this 2 meters. I'll make this 1000. Sorry, the height is actually going to be 2100, for example. And then let's say I want to centralize this. So this is going to be 1500. When you subtract 2000 minus 5000, you have 3000. 3000 divided by 2 makes it 15. So that is how we got this at the center. And then this height, I'm going to make it 100. Okay, and then I'll click on OK. Good. Now this is what we have. Let me come to window, vertical, to vertical, and then I'll come to my view, and I'll right click and I'll click on 3D view. So I want to have a 3D view at the side of this, so that I can see whatever is going on my 2D. I'm seeing it in my 3D as well. So I'm going to minimize this a bit, put this at the side. Now good. If you already love what you are seeing, make sure that you actually give it a thumbs up. Like this video, give it a thumbs up. Okay, subscribe to this channel. It's 100% free. You just look for that red button down below this video. You'll see where it is written subscribe. Just click on that red button and you have already subscribed. Okay, click on the bell icon so as to always get a notification whenever I post videos. I post videos like these on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of this land. Okay, so right now I'm actually going to be inserting my slabs on this. Okay, and then I will come to my slab and I will make this 200. Okay, remember I told you flat slab and beamless slab. Okay, so this dead load, I'm just going to use an assumed value of 2.5, and then this impose load, I will right click and I'll look for let's say this design is actually for shopping area. So now to insert my slab, sorry, I will have to do some little offset here on my grid. So I'll right click, I'll offset this, I'll hold on Control F2, or you just hold on Control or you hold on your F2, and then gives you the dimension. So I'll make this since this is actually at the center, I'll make this 225. Okay, good. Okay, no. Click on this, right click, offset. This will be 300. F2 300. I'm very sorry about this. Okay, alright, click. This is actually supposed to be 350. Okay, the drop panel is actually 300 700, so I'll make it 350. Good. Now I click on this, I'll set F2 350. Click, offset. Since I'm taking this down, it's actually going to be minus 350. Okay, minus 350. Good. So I'm going to insert my slab. I'll come back to my slab, click on slab, I'll make this 200. Come to my loading, self weight, dead load, I'm going to make it 2.5 for example. Okay, this is just, I'll come here, choose shopping area. Okay, as you know, your dead load is gotten from your finishes, your partitions, and then all of that. Okay, I have covered that on my RCD 2000 software, where I actually went in detail explaining how to actually get all of this. Okay, you can visit my channel to actually get some of those detailed information. Okay, so I'll come to my general, I'll click on insertion, I'll click on pick axis. Okay, and then I'll pick points. Okay, this is another point. Sorry, I think I didn't even pick that. Okay, you see it here. Sorry, supposed to go this way. Good. So I'll come here, pick beam region. Sorry, pick points, pick here, pick here, pick here, pick here, pick here. Good. I'll come here, pick here. Sorry, delete axis. Pick here, pick here, I'll pick here, and I'll pick here. Good. then I delete. I will pick here, and then I pick here, and then I pick here, then I pick here. Good. Now our slabs have been inserted in this. Now you can see it in your 3D. Okay, good. Now the next thing I'm actually going to do here is to generate all of this to all the floors. Okay, so I will right click on this, I will highlight rather, and then I will go to generate members to other floors, other stories. Okay, so I'm going to generate all of these up to story 6. Okay, and then I'm going to click on OK, click yes. So it's actually loading. Good. Now this is what we have. I'm going to close this. Good. Now you can see your drop. Now the major reason for this drop panel is to take care of the punching. Later in this video, if you stay to the end of this video, you are going to see how I'm actually going to check for the punching shear. Okay, right now I'll come down to my story 1, and then I'm going to add maybe like a partition for this slab. Okay, this partition, let's say we are doing for this, let's say the thickness is 150, for example. That's if you have a 6 inches block, for example, where you may decide to since it's a shopping mall, like a shopping area, you may have like maybe like woods or a glass that you use for partition. Okay, for the sake of this tutorial, I'm just going to be using the value of 2.15. okay. You can actually visit any of those reinforced concrete design books. I recommend Victor Oyenuga RCD 2000 RCC reinforced concrete design book by Victor Oyenuga. Okay, or you can get Mosley and Bongi or any of those design books that is actually recommended in your country. Okay, so I'm going to be using this sorry, I think that has gone off. I'll take that again. Okay, from here I'll make it 2.15. okay, so I'll drag, hold on my control, and drop. Yes, it's telling me load is not contained entirely within a single slab panel. Warning, okay, that the following cases slab loads will be considered accurate only in finite element model. So we're actually going to be using finite element model, okay, for this. Okay, so I'm going to click on OK, and then I'll hold on this, I'll hold on my control, and then I drop. Okay, click here, hold on my control, and I drop. So I click here, hold on control, and then I drop. Now see this, and then I right click. Now I can generate this member to other stories. Okay, I'll generate it to story 1, 2 to 5. Okay, and then I'll click on OK. Yes. Okay, it's generating. Okay, sorry, it may actually take a while. I think it's done now. You can see right now we are actually in story 6, okay, which is actually our roof level. So ideally we are not going to have a partition on this roof, so I'm actually going to take that off. I'm I'm going to delete this load entirely. I'll right click and click on delete. Okay, I'll right click and delete slab load. Yes. Okay, good. Now I'll come to my filter and then I'll select all and I click on slab. Okay, so by the time I highlight, only the slab will be highlighted. You will see what I'm saying. Good, you can see my slabs have been highlighted. So I'll go through my properties because this is actually a roof slab, so I'm going to actually reduce the dead load and I'm going to reduce the life load on it. Okay, because it's actually a roof slab, so I'm just going to be using one all through. You can see if I click here, I'll click on this table. Sorry, what is that? Come to my table and make it one. Good. Now I'll close this. Okay, so I'll turn off my filter. Now I'm going to close up this at the roof level, so there will be no opening at all. So I'll come to my slab. Okay, and then I'm just going to insert this slab here. Okay, good. Okay, good. The next thing I'm going to do right now is to actually go to my building analysis, and then I'll click on building analysis. Okay, you can see our parameters here. These are all BS8110. My foundation, the allowable stress of soil, it depends on from your soil test. Okay, so I'm actually going to leave it at 200 kilonewton per meter square. The soil subgrade coefficient, I'm going to leave it as that. It's actually from your soil test, so whatever results you get there, you input that value here. Okay, lateral loading, the title of the project, project header. Okay, so you can just give it a name, flat slab, or you can say propose flat propose shots. Okay, so made by, okay, let's degree, checked by engineer, okay, project number 001, for example, dates, what is the dates? We're in the month of November. Okay, like that. This is just a sample. The initial capital letter. Okay, so this E, make it capital letter and all that. Okay, this is just a sample of loading combinations. I will load generator, horizontal and load combination. For the sake of time, I may not explain wind loading, but I have explained wind loading on my former tutorial where I got where we calculated for wind load Okay, calculated for wind load. Let me just show you a sample of how it may look like. Okay, so you can visit my channel. Go down below the description of this video. You will find the link to that YouTube channel. You'll find that tutorial there where I calculated for my wind load. I generated all these values, okay, manually on this Excel sheet. Okay, you can actually visit that channel to actually keep yourself busy. So if you want to insert your wind loading, all I will need to do is just to check on this, but I'm not going to cover that today on this design. So load cases, I click on okay. Now these are different loadings, okay, that will be on that building. So you subject it to different load case. So you can see this is actually your wind load. You can come here and insert some of those parameters which we have calculated from here. You can see we have our RX here. So by the time you do your analysis, okay, your NY is actually going to be generated, and then the value you need to add here is the value for your RX, okay, which is actually not you input the value of RX, and RY you input the value of your XC1 and XC2. Yes. Now I'm going to click on OK. I'm going to leave it as it is. There's no wind load in this calculation because I just want to make this as brief as possible. Okay, so here finite elements. Okay. So I'll come to my analysis, but before then, my materials here, I can actually change my material for each of the structural members. As you can see, for your column, I can actually specify the size of reinforcement, the minimum size of reinforcement. The thing is, Protastructure is a very sensitive software that if you check on Y13, it will provide a reinforcement of Y13 for you, most likely. So this place is actually a very sensitive area that you should not actually joke with. Okay, so I'm going to be using 16, 20 and 25. So in my design, it will just pick around these three softwares. So it's actually going to make it it considers the most economical of this. Okay, so that is why if you choose Y13, it may most likely provide that as well. Okay, so I'm going to select 12, take off this, take off 13, 16, 20, 25, take this off. Okay, and then I'll click on OK. I have done a 10-story building, designing for pile foundation and raft. I included my pile cap, and then I did the calculation for this wind load in that tutorial. You can visit my channel to see that. Okay, this is actually a beam. For this beam, I'm going to make use of 16 from 16, 20, 25. I'm going to leave it as this like this. Okay, and then sorry, there is even no beam on this design. Sorry about that. So there's no beam, so I'm just going to use Y12 here, take off this 13, and I'll click on OK. Okay, so let me come to my links. So for my links, I'm just going to make it Y10, and I'm going to uncheck all of this. Okay, sorry, you can make it very easy to uncheck everything here. I just click on Y10, okay, and I click on OK, and then I click on OK here. Now another thing that you may want to know, this characteristic strength of concrete. You can make a choice here. This is 20/25, that is 20, which is actually the characteristic strength of your concrete. Okay, and then /25. I've explained that in my previous tutorials. And then this is the characteristic strength of your steel. Okay, so I'm going to leave it at 410 for all of it here. Okay, I'm not actually, there's no steel member on this my design, so I don't have to go there. Okay, so let me come to my building model check. I'm going to check for errors right now, and let me just check this and show you what I actually mean. Now you can see my model check completed. Number of errors is actually 88. Okay, now I think one of the major error is because I'm actually going to be having some columns that are actually going to punch at this slab. Okay, so I can uncheck check column inside slab panel. So I'm going to uncheck that, check overlapping columns. So if I go for that, you can see I have unchecked column inside slab panel. Okay, so because there is no beam on this design, so it's actually going to give me an error because there are no beams. Okay, so I have to uncheck this column inside slab because we are actually designing for a flat slab. Now you can see that there is no error on this anymore. Now the next thing I'm going to do is actually to click on that start button to analyze this design. So if you love what you're seeing, make sure that you actually give it a thumbs up. Okay, like this video, give it a thumbs up, subscribe to this channel. It's actually 100% free. Click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Okay, just look for that red button down below this video and you will find it. Just click on it and you have subscribed already. Now you can see it says the warning difference between the composed loads and slab loadings. Okay, yield line approach for beam load decomposition may not be adequate for this model. You can see the difference between building analysis result and undecomposed slab. Now it's up to 51.41%. So I'm actually going to be showing you this. Okay, I'm going to be showing you this in this video right now. Okay, and I'll click on OK. Now I'm going to be showing you this. Let's come to our axial load comparison report, and then we are actually going to take care of that right now. Okay, still loading. Okay, good. Now look at this. You can see this is actually the total dead load. Okay, this is actually the total dead load, which is 12,890.1. okay, and then if you come down here, the decomposed beam, you can see the difference from this dead load to this. You can see the difference. Okay, so if you check for the life load too as well, you can see there is a very large difference between this and these two as well, which is over 50%. Okay, So you can see, if you come down here, you can see what it says: the difference between building analysis results and undecomposed beam load is actually 51.41%. Okay, good. We are going to close this. Okay, let's go to model and analysis results. Now you can check for your displacement here. Okay, you click on displacement. You can see let's animate this and see. Now you can see these are actually different loadings. You can subject this to different loadings to see how this building is actually going to behave as regards to the load cases and the load combinations here. Okay, it's actually loading. You can see this is actually how this building is actually going to actually behave under this load. So click on the next load. Sorry, it's actually going to take time. You can see that it's actually loading, okay, because of how large the design is actually is. Okay, now you can see how it actually behaves under this other second load. Okay, so let's check for, let's come to load combinations. Okay, under this load, let's see how it's going to behave. Sorry, it's actually loading. Still loading. It's actually still loading. Sorry, the design is actually very large, so it may take a while. Okay, so I'm actually going to close this once it's done. Okay, so you can actually take your time and subject this to all of those loads. You can actually increase the scale. Sorry, it's actually still loading. So you can subject it to all of this load and test run and see how your buildings are actually going to behave as regards to each of these loadings. Okay. If you love what you're seeing, make sure that you like this video, give it a thumbs up, subscribe to this channel. It's actually free. Click on the bell icon so as to actually get a notification whenever I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to actually have a deeper insight of design. Okay, so I'm going to actually close this now. If you can remember, we have 51 up to 51 point something in our percentage. Okay, so I'm actually going to reduce that. I'll go to load decomposition. Okay, so when I come to load decomposition, I'll come to this my batch, and then you can see my uniformity here. I'm going to make it 100. Okay, okay, and then okay, I've gotten 100, and then I'll click on OK. You can see all of that has been checked. So it's actually loading. Says in order to increase the accuracy of the load transfer, use at least 6 frame member for each beam during mesh generation. Okay, so it's still loading. You can see it's at story 5 now. Okay, so by the time we are done here, we'll go and check that in our axial load comparison. So you can see we are actually at story 4 now. Okay, okay, it's actually a story 3. Okay, it's a story 2. Story 1. Okay, still loading. Okay, Now apply to all beams in the model. Okay, yes. So if we actually go back to our building analysis, okay, so it's actually going to save this. Come to my analysis. So let's check this again. Okay. So let me rerun this first. You can see it's telling me beam load calculated time, okay, 0.32 seconds. Okay, good. So the next thing I'm going to do is to click on my axial load comparison report. It's actually loading at the background. Loading at the background. Still loading. Okay. Now I'm good. Good. You can see now, always it should not always be more than 5%. So you can see the difference between this value and this value. Okay, you can see it's definitely not even up to 5%. So it should not be more than 5%. You can see the value we have here. Now this is 12,890. This is 13,055, 59.4. Okay, so let's check for the life load. Here you can see this is 4. It's actually even the same with what we have here. Okay, so which is perfectly okay right now. Okay, so I'm going to actually close this. Okay, so if I close this, the next thing I'll do is to go to post-processing. Okay, I'll go to my model and analysis. Take that again. Okay, so I'm actually not going to load all of that anymore, okay, because I will not want this to actually take much of my time again. So I'm going to close this. So but just like we did the earlier, so you can just check for all of those your loadings, okay. And then you can even switch this to your plan view, okay. So I'm going to close this. So the next thing I will do here is I'll come to my column / wall design, and then you can see that everything here is showing me that it has failed. So if I click on interactive, I can see this design for this particular column. I'm going to close this. I'll come to column design batch, and I'm going to reselect, and I'll design all of it. Okay, good. Now you can see that this has actually all been designed, and all our columns are very much safe, okay, which is perfectly okay. So the next thing I will do is to go to finite elements, okay, floor analysis, okay. I can go for my creep, okay, and then insert the dead load and then the life load if I want to, for creeping, and my crack, okay, for my crack and my creep, okay. And then for here I'll just come to my batch FE chest down, okay. So at this point all I'll do is to tick on all of this, okay. And then this, I'm going to make this 0.25. I'll make this 0.25, and I'll make this 100. Sorry, 0.25 means 0.25, okay. And then I click on continue. So it's actually loading. So it's at story 5 now. So it's at story 4. Okay, it's a story 3 now. Okay, good. If we come back here, you can see our floor mesh and analysis. I would have done for, okay, I'll come to analysis post processing. Okay. Okay, I pan this up. Now you can see my mesh. Now you can see the mesh is actually quadrilateral. Again, the value from now the smaller the mesh, the more accurate value you get. Okay, so sometimes you can use 100. Now that will may actually take much of our time, so that is why it is actually 100 and 800. Okay. Now you can see we have standard contours, we have user defined, we have threshold. Now for your user defined, you can see these are moments. This is for bending. Okay, you can see for bending. This is for the required steel. Okay, this is actually user defined. If I click on edit contour, you can see we have numbers of contours. We have 8 of it. I can reduce the number of contour to 6, for example, and if I'll click on update. Okay, you can see it has updated. You can see the reinforcement here is actually Y12, but that can actually be changed. Now these contours, you can see we have 6 of them right now. Okay, so yeah, 6 here. So we have 6 right now. Okay, so then I'm actually going to take it back to 8, and I'll update and I will interpolate this. So if I bring this back here, you can see the maximum value here is 326.17. okay, this is actually the required steel area, but I can make provision for a value that will be a bit greater than this value, which will make it safe. Okay, So if I make this spacing, let's say 150 for example, and let's see what we have. 150, you can see the value has not actually really changed that much. Okay, so what if it is 200? Okay, good. So let me make it 250. You know, in design, your design should not just be safe, but should always also be economical. Okay, so you can see this is actually a bit higher than 326, which I can actually leave this as it is. You can see we have Y12 at 300 spacing, so I can actually export this particular contour. Now I can do for all these areas of my steel. I'll go to edit contour. Okay, this is actually user defined. Okay, just the same thing, just like the way we did initially. If I make this I think 300 now is perfectly okay for all of this. Okay, I'll export this and it's okay. I come to 3. So this is what I will repeat all of this for all of them. Or I can actually use the threshold. Okay, for the threshold I click on this. I will set a nominal steel. Okay, the reason why I'm having just one reinforcement here is from my selection of reinforcement. I think only Y12 is actually selected there. That is why it is actually like this. Okay, like if I had selected more than one size of reinforcement, I would have seen the list of those reinforcements down here below. Okay, so the spacing of let's say 300. Okay, for the area of my steel. Now you can see I have a whole lot of these areas are actually green, but you can see some part of it that are not showing green. Okay, that means part has actually failed. Okay, so I can as well reduce or increase my size of reinforcement and then reduce the spacing. Let's say we have 200 spacing, for example. Now you can see the red portions have actually reduced. Okay, so if I go back again and I make this let's say 150 for example, and I click on OK and I click, now you can see it keeps on reducing. Okay, I can still go back to my edit contour and I can specify the minimum. Okay, this is actually the maximum. I can specify the minimum to be let's say 100 for example. Okay, and then if I come here and I set, okay, and I make this 100. Sorry, let me make it 0 back. Okay, good. You can see what we have here. And then let's close this. Wood and armor in slab design moments. Okay, okay, good. Now the next thing I'm actually going to do here is to I'll come back to my slab and then I'm going to actually strip them. Okay, and then I'll come to my story 1. I'll go to my slab strip and I'll come to my FE. Okay, my slab strip, I'll make this FE strip. Okay, and then I'll come here, I'll select for this. Now take note of this. This is actually at y-axis, so sorry, x-axis. So these are my x-axis, these are my horizontal. Okay, so I'm going to the one I actually choose there, you can see from the name, fixed band strip. Okay, this is for across your support. Okay, so here, if I come down here, my left hand here, I can reduce this to, let's say, 300. Okay, and then I'll update. Good, you can see what we have. I'll make this 1000. I'll strip this to this point, and then I come here, strip. Okay, leave it. Come here, strip. So at the mid here, point here, I'm going to strip that too as well. These are for what? I can hold on control to have a straight line. Okay, sorry, that didn't work. So here I'm going to take this to this point. Okay. Okay. Take this to this point. Sorry about that. Sorry, it can actually be frustrating sometimes, so you have to actually patiently take this. Okay. Sorry, let me zoom this so I can see what is going on here. I don't understand why it's not working. So I'll hold on control. Hold on control to make it straight. Sometimes you have to zoom in order to see this, and pick, hold on control. Okay, good. Then I'll switch this to my vertical, and then from my support here. Okay, so I have my left and my right. So my left here, I'll make this 300. Okay, sorry, this is 1000. This is 1000. This is 300. Updates. Good. And then I'll make this 1000. Pick it here. And I drop. Pick here. Pick here. I drop. Pick here. I'll make this 300. Good. Now I'm going to take the midpoint of this, so it's better you zoom. Let me take this. Okay, take this 1000 bits. Take this 300. Okay. Okay, I've taken that already. Okay, good. Did this, and then I close. Okay. So after doing all of this, the next thing I will do is to actually go back to my building analysis. I'll come to my building analysis. So on my building analysis, I'll come to Finite elements floor analysis. Okay, so everything here is okay. I'm going to close this. Let me check that again. If I click on OK, it's actually going to rerun that, which I don't want. Okay. Go to my post processing. Okay, it's actually loading in the background, so control. mesh contour. I'll come down here to my area of steel. And then I edit contour, set nominal. Okay, click on OK. You can see I have some other little red indication, but I'm not going deep into that. Okay, so I'll go to my next area of steel. Edit contour, set nominal. Okay, good. I'll export. I'll come to the third one here. I'll edit contour, set nominal. Okay, I export. Sorry, you can see I have, let me take this again. Let me reduce this spacing to 200. You can see I have a lot of red indications here, so I want to, how you can see it has reduced. Let me make it 150. Okay, good. I'm going to export this. I'll come to this fourth one. I'll edit contour, set nominal. Let me make this 200. Okay, so I'll export. So let me check for displacement. Okay. You can see those
contours that are far from the support tend to have the higher number of displacement. Okay, and then this one for displacement. Okay, so close this. So it's actually transferring the slab strip result. Okay,
so allow that to actually finish transferring the slip, the strip rather. It's actually still transferring those strip. Okay, Okay, it's actually still loading. So after we're done with this, we are going to check our punching. Okay, check for punch. Oh, it's actually still loading. So we have we have 11 of 13, we have 12 of 13, 13 of 13. Okay, 11 of 13, 12, 13, 13. The strips are actually much, so that is why it's actually taking this time. Okay, remember we have six stories, okay, on this, so that is the reason why it's taking much of this time, okay, to transfer all of those values. Okay, so it's generating the result loading right now. It's actually done with the strip. Okay, it's actually almost done. As you can see, these were the strips actually we did on this. Okay, these are actually this is actually covering it. So these are the strips, the ones we did on that support. Okay, these are the ones we did on the middle. These are the one we did on the other support. This is actually that core wall area. Okay, you can remember I did one here, I did one there. Sorry, it has gone off. That has been done. Okay, so I can just close that. Okay, so I'll come here and update my steel bar. So it's actually updating it. It will provide the size of reinforcement and my reinforcement on this design. Okay, you can see I have Y12 at 250 spacing. Okay, for top bar I have Y12 250 for my bottom bars. Okay, so that is that. The next thing I'm going to do here is to actually check for my column punching check. Okay, so I'm actually going to check for this. I'm going to check for column perimeter. I will check column drop panel because I have a drop panel here. I'm going to include column, wall and beam edges. Okay, so I will design for this. So it's actually loading. It may take a little while as well. Okay, so okay, I think it's done. It's loading right now. Okay, now you can see that the punching check, you can see it's actually adequate. So in a case where I don't have at a point where it's not adequate, I will have to actually increase maybe increase the size of my slab thickness, or I'll increase my drop panel, the width and probably the thickness, okay, of my drop panel. Okay, but everything here is actually showing me that is adequate. Okay, so if that is very much correct, so I'm going to close this. Okay, then you can actually print that result in PDF. Sorry, I have already closed that page. Okay, so if you love what you have seen, make sure that you like this video and then give it a thumbs up. Okay, like this video, give it a thumbs up. Okay, subscribe to this channel is 100% free. Okay, you see a red button down below, just click on that red button and you have already subscribed. Okay, click on the bell icon so as for you to always get a notification whenever I post videos, because I do post videos like this on a weekly, sometimes on a daily, so as to encourage as many that actually have a deeper insight of design. Okay, make sure that you stay safe and make sure that you stay blessed. Another thing, register with us. If you have a challenge, we can guide you, we can mentor you on designs. We take you through the process of design for 40 days. Okay, guide you through the process with the softwares, guide you on how to install it and how to crack it on your system yourself. Okay, and then we'll train you for 40 days. Stay safe.